Okay, so let's say you just finished your first AP Biology lab. You were testing, like I explained in the lab format, you were testing to see if pill bugs preferred a dry environment or a moist environment. So you did two tests. You did a control test and you did an experimental test. And in those tests, these are the results you got. You found that 18 pill bugs preferred side B and 12 preferred side A in the control. And in the experimental, where side B was moist and side A was dry, 22 bugs preferred side B and 8 preferred side A. Now we have an important question when we look at this. We know that the pill bugs preferred side B. There were 18 over here and 12 over here. We have 22 over here in the experimental and 8 in side A in the experimental. So obviously there were more pill bugs in side B each time. But the question is that real? Is that a pattern? Do pill bugs always prefer side B? Or is this simply random? That's an important thing to know because you don't want to go to the scientific community and say, I figured it out. All pill bugs prefer side B of a control, of a choice chamber, and then discover that that was actually just random chance. So in order to figure out if it's random chance, we do a statistical analysis called a chi-squared test. And this is the chi-squared equation over here that we use to figure that out. The chi-squared part is right here. Chi is this x-looking thing, and obviously it's got an exponent on it. And then this is the actual equation we use to figure out the chi-squared. The important things we need to know in here are this big sigma symbol, this guy, which means just the sum. So you're going to add up all of the stuff to the right of the sigma. The other things that matter are the O. O stands for observed. This is the actual data that you measured. So the things in this chart are my observed data. I observed 12 on side A and 18 on side B for the control. The E in the chi-squared equation, which shows up twice, stands for the expected values. So we're going to be comparing the observed data that we actually got to the expected data that we thought we would get if this was just random variation. Okay. So how do we figure that out? Well, first of all, we need to think about what did we actually expect? And what we expect to have happen is if it's just random chance that the pill bugs are choosing side A or side B completely at random, we expect that half of the pill bugs would go to side A and half would go to side B. So it's expected that because there are 30 pill bugs, that 15 would be on side A and 15 would be on side B. That's our expectation. Now that doesn't match what really happened. We had 12 and 18, but the question is maybe it's pretty much random. Okay, so we're going to compare what we actually saw to what we'd expect by using this equation. Okay, so we'll actually plug into our chi-squared. Because we have side A as an option and side B as an option, we're going to fill in this equation for both side A and side B. So we'll take the observed value for side A minus the expected value for side A. We'll square them, and then we'll divide by the expected value for side A. And then we'll add that, we have to sum it up because of this sigma, we'll add that to the observed values for side B minus the expected values for side B. We'll square those, and we'll divide by the expected values for side B. All right. So we've got what we end up with is our chi-squared will actually be the observed value for side A, which was 12, minus the expected value, which was 15. You square those. And you're going to divide by the expected value for side A, which was 15. You're going to add that to the observed value for side B, which was 18, minus the expected, which was 15 again. Square both of those, and divide by the expected value, which once again was 15. When you do that, you're going to find out that your chi-squared value is 1.2. Now, what does that mean? Well, in order to figure out what that chi-squared value means, we need to actually decide what is our threshold value. So the point is, the more unlikely something is, the higher the chi-squared. This is a measure of how unlikely is it. Okay. And the higher that unlikeliness, at some point it reaches a level where it's just too unlikely. We just can't believe it. And I'm going to post another video on this page that talks about how you figure that out. But for right now, in the tests that you're going to be doing, we're just going to say that anything, if chi-squared is greater than 3.84, then we're going to say that it is too unlikely. So that means it's not random. But if chi-squared is less than 3.84, we're going to say that that was random. It's unlikely, but not that unlikely. Okay, so since the chi-squared for our control data is 1.2, we're going to say that that was random, that the bugs were not preferring side B, they were just picking at random, they didn't care. On the other hand, if we do the chi-squared for the experimental data, where there was actually a wet side B and a dry side A, let's see if that was random or not. So in that case, we had the observed for side A was only 8. Once again, we still expected random chance. We still expected 15 on each side. And the observed for side B was 22. Now that seems like a lot, but until we do the chi-squared, we don't know if it was random chance or not. When we calculate that, we're going to find that chi-squared in this case was 6.54. So for the experimental group, it is greater than 3.84, which was our threshold value. And so we assume that that means that that wasn't random, that in fact the bugs did actually prefer side B to side A. So you can see why this is an important tool, especially in biology. You have to prove that animals aren't just behaving at random. You have to show that there's some real principle guiding their behavior. And chi-squared is what allows us to do that. It's what allows us to rule out that question of, well, how do you know it wasn't just chance? And so this same chi-squared analysis is something you're going to be doing in your lab report that you're writing over the summer. I'm going to post on this same page another video that is much more in-depth than this. You only need to watch the video I'm making right now in order to answer the Google form on this page. But if you want more in-depth, which you will get later in the year from me, if you want more in-depth right now, feel free to watch that other video, and I hope that it helps.